equal vector and negative vector. To understand these two concepts, let us take a vector OA, O as tail and A as head. Let us consider the vector with tail O and head A. This can also be represented with a single letter capital A with a arrow over it. This represents the vector. So, capital A with an arrow over it, represents say this vector OA. Sometimes we represent the magnitude of this vector by only the letter A. Capital A represents only the magnitude. If an arrow mark is drawn over it, it is termed as a vector. I have drawn several vectors, one green one, the rose one, blue one, and these three. By observing these three, what we notice is the blue one, the light green one, is not of same length as OA. So, its magnitude is less than that of the first vector A, but it is parallel to OA, its direction is parallel to OA, hence its sense is the same, but magnitude is not equal, hence this is not taken, hence it is not considered as an equal vector. Consider the rose one to the right of it. This is having the same magnitude, that is, the length of this vector is same as that of A bar, the vector A, but its sense and the direction is different, hence this is also not equal to the vector A. Let us take the blue one, which has the same sense and same magnitude. The length is the same and the direction is the same. So, this is taken as an equal vector to A. So, if there is a vector, this vector can be represented at any point with a vector of same length and same direction. Like this, we can shift the vectors from one point to another point in a plane. If there is a vector having same magnitude but opposite sense, it is known as the negative vector of A. Consider the bottommost right side vector. Its direction is opposite to the direction of A bar. A bar is situated from left to right, from O to A, and this vector is from right to left. But the length of this vector is same as that of OA, but its direction is opposite. Such vector is taken as the negative of the vector A bar, the negative of the vector A bar, and it is written as minus A bar. Minus A bar. This is negative vector of A bar. Vector addition. To understand vector addition, let us take two vectors P bar and Q bar. Let us take two vectors P bar and Q bar. I have drawn two vectors in the plane. P bar is larger than Q bar, and their directions are not the same. They have different directions. To find the sum of the two vectors, we use head to tail rule. Here I am going to add the vector Q bar to vector P bar. Then we will get P bar plus Q bar. P bar plus Q bar will be obtained by adding Q bar to P bar. That means, at the head of P bar, attach the tail of Q bar. Draw the vector Q bar such that its tail is at the head of P bar. So, this is head to tail. From the head of the first vector, the tail of the second vector will be drawn. Head of the first vector is taken as the tail of the second vector. Hence, this is known as head to tail rule. Now, in the figure, I have represented P bar by OA, P bar by OA, such that A is the head of the vector P bar, A is the head of the vector P bar, and I have taken A as the tail of Q bar and AB is the vector Q bar, AB is the vector Q bar. Then OB, the vector OB becomes P bar plus Q bar. The vector OB becomes P bar plus Q bar. Like this, we add the vectors. Like this, we add the vectors P bar and Q bar. This is known as addition principle of vectors. Subtraction of vectors. In arithmetics, subtraction is nothing but addition. So p bar minus q bar can be taken as p bar plus minus q bar. That means by adding minus q bar to p bar, we get p bar minus q bar. P bar minus q bar is obtained by adding minus q bar to p bar. Take the vectors p bar and q bar. First draw minus q bar vector, then draw p bar vector at the head of p bar. Let us suppose OC represents p bar, then C is the head of p bar. From C, let us draw the vector minus q bar. The head of the vector is say D, then OD is p bar minus q bar. So OD is p bar minus q bar. A stone of mass 2 kg is placed on a smooth horizontal table. A stone of mass 2 kg is placed on a horizontal table, smooth horizontal table. It is pulled in two perpendicular directions by applying two forces, say 4 newtons and 3 newtons. 4 newtons and 3 newtons. Describe the nature of its motion. What is the nature of its motion? Now I am going to represent the body of mass 2 kg with a dot on a paper. Then the forces 4 newtons and 3 newtons are represented by the two vectors. I am taking two vectors, one of 4 centimeters length, the other of 3 centimeters length, and I am drawing these two vectors perpendicular to one another from a point. The point indicates the stone and the vectors represent the two forces applied. Then let us complete the rectangle with the vectors 4 newtons and 3 newtons. Let us name the vector 4 newtons as OA and the vector 3 newtons as OB, and complete the rectangle OACB by drawing a parallel vector at A equal to OB, by drawing a parallel vector at B equal to OA. Then we can complete this rectangle. I am drawing the diagonal that passes through O. I am drawing this diagonal OC. From O to C, the diagonal is drawn. This diagonal represents the resultant force. Now let us evaluate. Let us find the magnitude and direction. Now let us proceed to find the value of the magnitude of OC and its direction. If we consider the right angle triangle OAC, I am considering the right angle triangle OAC. In this triangle, OA is 4 and AC is 3 and OC is the hypotenuse. From Pythagoras theorem, we will get the value of this hypotenuse is 5. So the two forces 4 newtons and 3 newtons, they can together apply a force of 5 newtons. They apply a force of 5 newtons in the direction OC. Along the direction OC, a force of 5 newtons is experienced by the stone. So the acceleration created by this force is obtained from F is equal to ma. So F is 5 newtons, mass is 2 kgs. So acceleration is equal to F by m, that is equal to 5 by 2, which is equal to 2.5. The forces are measured in newtons. Hence the mass is taken in kgs. So we are considering SI system. In SI system, the unit of acceleration is meter per second square. So A is equal to 2.5 meters per second square. The resultant force of 4 newtons and 3 newtons, it produces an acceleration of 2.5 meters per second square. Now let us explain this direction. Let's explain the direction of this acceleration. Generally, the direction is expressed with the angle made by the resultant OC with OA. Resultant OC with OA. By supposing the angle between OA and OC, as alpha, I am representing the angle between OA and OC by alpha. Then from trigonometric relation tangent of the angle alpha, we get tan alpha is equal to 3 by 4. Approximate value is about 37 degrees. So the acceleration is created at an angle 37 degrees with the direction of the force of 4 newtons. The magnitude of acceleration is 2.5 meters per second square. Like this, we can solve the problem. In the previous problem, I have considered the forces acting on a body. We can also take vectors like velocities of a body. We can apply vectors for finding the resultant velocity of a body. Suppose a body is moving horizontally with a velocity 4 meters per second. Then another velocity of 3 meters per second is created by applying a sudden force. A velocity of 3 meters per second is created perpendicular to it. Then by drawing the rectangle, once again we notice that we get the value of the resultant velocity as 5 meters per second, and its direction will be approximately 37 degrees with the 4 meters per second, with the velocity 4 meters per second. Like this, we can use these vectors for displacements, for velocities, for forces and accelerations, whatever may be the vector physical quantities we consider. We can apply these vector concepts and find their resultants by applying parallelogram law.